So again, today we'll be talking about delivery and forwarding of the IP packets in the layer 3, okay, routing. All right, so the network layer number 3, layer number 3 is responsible. There is direct and indirect delivery. And we will discuss the forwarding of packets in the network layer, how the packets are forwarded in the network layer, and then we distinguish between destination address based, so we forward based on the destination address, and a label based address. Okay, we'll see the difference. Then we discuss the difference for the different forwarding techniques. So we'll learn about what's next hop, right? And we'll then network specific. We'll learn about host specific. So the host specific is one thing, and network specific, and we'll see the default. We'll discuss the contents of the routing table. What is routing table? So the router is a device. We call it multi-homed device because it connects at least two networks, right? It has at least two network cards, all right? So, but how the routing is happening, there is a routing table there, and the routing table runs through a routing protocols. So there is different routing protocols that run on the router. All right, and that depends. And also, we'll take a look at routing tables in the classful. Okay, classful. What does it mean? Classful? Class A, B, C, right? Okay, or a classless. Remember the cider with the slash last time we spoke about the slash is a classless, the classless network, right? So there's a classful and a classless addressing. We discussed them very well last week, and you need to do the homework. You'll learn a lot when you do the homework. Okay, we'll take a look at the algorithms because routing protocol is just basically an algorithm. That's what is a protocol. Okay, and the algorithm will search the tables. The tables has information like a map, and the algorithm will search the tables. Then we'll introduce you to the MPLS technology, all right, which is a connection-oriented protocol system. So IP. Let me ask this a question. Remember when we discussed the protocols, we said if we need to define the protocols into divisions. Some of the M protocols are connection-oriented protocols, and the others are connectionless, right? Okay, so connection-oriented is like what? Like the phone system. So there is delivery guarantee, right? And connectionless, there's like the mail system. There is no guarantee for the delivery. Remember? So we gave examples in the transport layer. So in the transport layer we have UDP and we have TCP, right? So TCP is connection-oriented protocol, and the UDP is connectionless-oriented. How about the IP? IP is it connection-oriented or connectionless?
Connectionless.
It's a connectionless oriented. So that's how it was designed originally. But nowadays they're trying to make it a connection oriented by using the MPLS technology, and that's based on it's a label based forwarding. We'll take a look at that. We'll see how it works. All right, then we list the components of a router and explain the purpose of each component. So there's multiple components in the router. Let's take a look at them and what are the purposes of these components and what their relationship to the other components. So router is built of components, CPU, Ethernet network cards, etc., and RAM and all of that. We're gonna take a look. So that's what we'll try to cover today. So we'll talk about delivery. What are we delivering in here? Pizza?
We're delivering the package.
Packets, not pizza, right? Yeah, well, I mean, it would be nice if we could deliver pizza, all right? But we are delivering packets, all right? And forwarding, what does it mean? The destination and the source, they are apart from each other and they have to go through routers, right? So the router, what the other name for the router? Store and forward. Store and forward. To receive the data, store it, and forward it. Okay, find the path, store and forward. And then we'll take a look at the structure of the router. Deal, okay, good deal. Is it a
Yes.
good deal for today? All right,
Yes.
all right. So, so moving on. So let's take a look at the delivery. All right. So the network layer is the layer 3, or the network layer, supervises the handling of the packets. All right. So it receives the packet from the underlying physical network and moves it up, right? Right? Or it receives it from the transport layer and moves it down. All right. So we define this handling as the delivery of the packet. So the layer 3 job is to deliver the packet. All right, to the destination. This delivery of the packet is the final destination. So we don't care about delivering it to the next hop and next hop. I mean, the goal is to go to the final destination. It might go through one router, might go through multiple routers, 2, 3, up to 15 router until it gets to the destination. So for that, there's two different methods for in delivery, which is and direct and indirect. So direct and indirect delivery, as we'll see. All right. So let's talk a little bit about the direct delivery, then the indirect delivery, and I think you could understand this very easily, right? So in the direct delivery, as you see in here, there is a source A, source B. They are connected with a switch, so they are part of the same network, right? Otherwise, we'll not be able to communicate. It's the same LAN, right? So the final destination of the packet in here is a host that is connected to the same physical network as the deliverer. So they are in the same network. So that means if we are using layer C class, so the network part of the IP address will equal the network part of this IP, or the network part of the IP address of B, right? They are in the same network. All right. So for that, because they are in the same network, we don't need a router. It will be like a direct connected transmission. It will not go through the router. Okay, so the sender can easily determine if the delivery is direct. How it could do that? By extracting the network address of the destination. So source and destination, it will extract the network address of the destination. If it's equals to the network address of the source, then they are part of the same network. There is no need to send it through the router. It will be a direct, all right? So, and that's what we learned last time. We learned the IP address has two parts. The first part, okay, the first part is what?
That's the network ID.
The first part is the network ID, and the other part is
Host, host ID.
all right. Are you guys studying, or you're too busy like me? I think you are busier than me nowadays, right? So let me take a look in here. Let me say create a new one. So for example, okay, if we have a switch, maybe let's pick something switch like that, right? What like that? So so I need to draw something, guy. I don't want to measure. I don't want to use text. I want to use this. So why is not allowing me? It's really interesting. Try again. Try again what? Hmm. That is really interesting. Why do I select anything? Okay, in here, add note, insert menu, paste, whatever, follow, PDF. I don't want any of this. Just I need to. Come on. Really? Okay, let me close this completely. Let me close this completely. And let me bring this in here. All right, guys. So last time, okay. So for example, if I have a switch in here, okay, that's a switch, right? And I have a node, okay. Let's call it A, and another node. Let's call it B, right? And let's give it an IP address. So for this 192.3.3.4, and this 192.3.3.10. So, do you think these two nodes will be able to communicate or no?
Yes, yes.
Yes. Why?
In the same.
Because they have the same network address, right? In the IP address. Remember, in the C class, this is C class, right? So,
Yes.
so it's like the subnet mask 255 dot
255.
255, right?
255.
Dot
That's there.
255
That's there.
dot 0, right? And it's the same here, right? So if I, okay, in here,